y equals sine of x over e to the power of x. Now we're going to differentiate this a number of times. It would probably be easier if we wrote it as a product. The product rule is easier to manage, and it's much quicker than the quotient rule. So we'll know about the first derivative, dy by dx. So differentiate the first, leave the second, and leave the first, and differentiate the second. Now I'd like to tidy that up. I think I'm going to move the e to the minus x out to the front, and that gives me cos x minus sine of x. That's the first derivative. The second derivative we denote d2y by dx squared. Now we have a product here. Here's u and here is v. So applying the product rule again, differentiate the first, leave the second, plus leave the first, we differentiate the second. So we have to differentiate both of these terms. When we differentiate cos, we get minus sine of x, and when we differentiate sine x, we get cos of x. Now I'm going to simplify again by taking out e to the minus x as a common factor. This negative here, you'll notice that I haven't taken the negative out. So this negative here makes this term positive and this term negative. So I'm going to have sine of x minus cos of x. Now I'm taking out e to the minus x as the common factor. These don't change. So it's minus sine x minus cos x. And we can see that the sine x's cancel. And what we have then is e to the minus x, 2, in fact I don't need a bracket, it's 2e to the minus x cos x. That's the second derivative. So we'll do one more at least. So d3y by dx cubed. So we're differentiating, simplifying, differentiating, simplifying. It's a reasonably straightforward process. So here is u and here is v. If I differentiate the first, I get minus 2 e to the minus x times cos of x. If I leave the first and differentiate the second, I get minus sine of x. I'm going to take out 2, I could take out minus, in fact, minus 2 e to the minus x. And that gives me cos of x plus sine of x. I'm going to differentiate for one last time. So here is the first, here is the second, here is u, here is v. So if I differentiate the first, I get 2e to the minus x, leave the second, if I leave the first, I differentiate the second, I get minus sine x plus cos x. I'm going to have to simplify, so I'll take out 2e to the minus x, cos x plus sine x. Now what I'm going to have to do, if I take out the 2e to the minus x, that means we're left with a negative, so negative negative gives us positive, and negative positive gives us negative, and then we have the cosine terms cancelling, and 2 sine x times 2, so that's 4 e to the minus x sine x. So this is where we're at just now. What I'm going to do is to bring the e to the minus x down onto the bottom line. Now you may remember that we started with sine x over e to the minus x, and that was defined as y. So d4y by dx4 is in fact 4y, and that is all you need to know about higher derivatives.